Hello, this is Nick Barbuto from neweconomyengineer.com, and I'm here with David Goldberg today. So David Goldberg is the co-director of the iFoundry. It's the Illinois Foundry for Innovation in Engineering Education. And he's come here to talk with us about the idea of his entrepreneurial engineer and hopefully his insight on the new economy engineer and what we're studying with that. Why did you write the entrepreneurial engineer?
Well, so it's interesting history behind the book. In 1976, I left the University of Michigan with my master's in civil engineering and worked for a small entrepreneurial firm in Carlisle, Pennsylvania called Stoner Associates. And I thought at the time that I was going to be programming advanced computer programs for simulation of gas, water, and oil pipelines. And I did a lot of that, but I also was sent on sales calls and to do customer service and many other things that I was unprepared for. So in some ways, the writing of the entrepreneurial engineer was a reaction to this entrepreneurial experience I had many years ago, and thinking about how students today are confronted with the ability to go beyond their technical skills and perform in a business world, in a world of customers, in a world where maybe not the most important things are the technical side, but whether or not customers are gained and retained.
So, you mentioned design, and that seems to be almost a buzzword in today's engineering curriculum, that innovation, entrepreneurship. And there are a lot of other topics that engineers it would be handy for them to know: management, accounting principles, intellectual property. How do you fit all of that into a curriculum? I mean, without going 6-7 years down the timeline.
Your question's a good one, but it's loaded in a number of ways. So the first way in which it's loaded is the use of the term fit. The term fit assumes that everything that we're currently doing has to be preserved as is. Some of the other parts of your question had to do with words that we use, like design, for example, is a good word. It does actually characterize much of what we want, but if you ask people what design is, you'll get many different answers. And so there are many terms that we use, there are many words that we use that are abused in a sense, that we use them as sort of catchphrases for things that we don't articulate very well. So for example, design might mean that you need to go out and understand the problem it is that you're trying to solve fairly well. That's a part of the, quote, design process. But it doesn't get at what are the skills that somebody needs in order to understand the problem well. And so it seems to me that some of what we need to do is break down some of these code words we use and be a little bit clearer about what we mean by them.
So, how do you then motivate the professors to teach that sort of thing, as well as kind of motivate students to learn it? A lot of students will be, I want to be an engineer, I want to know my calculus, I want to know the strength of materials, and I don't need any of this intellectual property. How do you motivate them?
Yeah. So I think, so some of it comes from understanding the history of how we got to where we are. If you examine the current curriculum didn't exist forever. The current curriculum is basically an artifact of a report in the 50s in this country called the Grinter Report. It's 1954, I believe. And in that curriculum reform, elements of the practical side of engineering were removed, and math and science and engineering science were injected in strong measure, and what we call design was removed. So some of the things that were traditionally part of what it meant to be an engineer were removed, and some things that came about or some other elements were injected. So I think in order to have faculty and students embrace further changes, we need to understand first, why were those changes made, and ask the question, were those good changes? Or also ask the question, well, maybe those changes were good then, are they still serving us well now? And so it seems to me that we need to probe and understand, at least in an outline kind of way, where these things came from. So you used, actually, I think you used the term the basics in your question. And the basics is another one of those terms that we use that is a loaded term. So what do people mean by basics? They mean math, science, and engineering science. But as I just said, the basics weren't always the basics. So the basics were something that was adopted at a particular point in history in response to certain societal pressures. And so the question is, are the basics still the basics? And I would answer this way, and I think this is fundamental, because you can argue about, do we need an intellectual property, do we need accounting, do we need this, do we need that, and different people will have different lists. And a certain amount of diversity along those lines is actually a good thing. We have different departments for exactly that reason. But the question is, are there thinking skills that are being missed that are fundamental to what it means not only to be a good engineer, but to be a good citizen and a good critical thinker? And I think the answer is yes. There are things that are being missed. So, for example, going back to my discussion of senior design, the students go out on the job. They go out to solve this industry problem. It's a perfect time to probe what it is they don't know. First thing they don't know how to do is how to ask a good question. You coach, as their advisor, I coach them. I get them to ask some good questions, and they get enough information. Then they bring that home, and then what they know how to do? They don't know how to label the things that they've seen. Either they don't know the names of existing technology, and there are patterns in the data and patterns in the conversation that they've had with their companies that they don't know how to give names to. Then what don't they know how to do? Well, then they don't know how to model those things qualitatively. If they can plug into Newton's laws or Maxwell's equations or use calculus, boy, that's a great thing, but these companies aren't paying $8,500 to solve a simple problem with Newton's laws. They're paying this usually because it's a problem that they've tried to solve and they failed. And so the reasoning processes that they have to use involve qualitative reasoning that the students are not particularly skilled at. Well, then what don't they know how to do? Well, so they don't know how to question, label, or model qualitatively. Then they don't know how to measure things. So we teach, again, plugging into equations, they can do that, but when it comes to turning to the world and measuring something, that's not a first impulse. Then what don't they know how to do? Well, then they need to decompose this big problem into smaller problems they can solve, and they're not very good at that. They don't know how to brainstorm or have ideas in a creative kind of way. How do you do that? And then finally, at the end of the day, we've coached, and finally we have a finished product, and what don't they know how to do? They don't know how to communicate the results to the client. They can't present, standing up and giving, say, a PowerPoint presentation, and they don't know how to write a coherent engineering report appropriate to business, say, as opposed to writing an essay for some English class. They don't know how to communicate as engineers, as business people, and so my list had 7 items in it. Those items, none of them had anything to do with math or science. They were all qualitative thinking skills. Sometimes the term is used, metacognitive skills. Those skills are thinking about thinking skills. Those are skills that help you get into the right ballpark. And I would argue that those are the kinds of things that are actually are universal, regardless of the flavor of engineer that you want to be, and regardless how important you think the business side is, or how important you think it is to reason ethically. The ability to reason qualitatively and label things and ask good questions sometimes the term critical thinking is used. Those critical thinking skills are crucial to being able to be a good engineer, to be a good scientist, to be a good citizen. And it seems to me it's those things that we're not doing very well. It's not just a failure of engineering education, it's a failure of general education writ large.
Well, all these things I think are very important, and I think a lot of people will agree, especially moving into kind of the new economy that we have after the wonderful crash we just experienced on Wall Street. So, with this new economy, with the flattening of the world, as Friedman would say, how do all these play in the business world? Are business people willing to pay a premium for this at the moment, or should it just be standard?
Well, so I think so you raise some really interesting questions. And so for me, one of the ways into the entrepreneurial engineer was thinking about how our world is different. And thinkers like, you mentioned Friedman, we could also mention guys like Richard Florida, The Rise of the Creative Class, or thinkers like Dan Pink, the need for a whole new mind in his estimation. It seems to me that this confluence of people singing from the same page and singing from the same hymnal is not an accident, and it's partially a response to the technological and economic factors that govern our times. And if you look at, I think, go back to the Cold War and the rise of the Cold War engineer, that was a response to what? That was a response to organizations that were large, hierarchical, economies of scale dominated. And so in some ways it made sense to create narrow technical specialists to serve those interests. But if you then come forward to where we are in 2009, there have been a series of revolutions that have taken place in industry that have not taken place in the academy. So, for example, we can look at the quality revolution. So the whole revolution in making quality products started with ideas generated in the United States, went to Japan, came back as a result of the crisis of the Japanese onslaught in the automotive industry, and American industry adapted, at least somewhat, to those pressures to become higher quality producers. If you think about it, that was a big revolution that took place, but it didn't affect the academy very much. Now, in some sense, that's a missed revolution. It affected industry, but it didn't affect the academy. Now, we teach quality methods in the academy, but you cannot argue that the university itself is a quality institution. Imagine trying to get ISO certification for any of our universities. I'm not just picking on Case, but any of our universities, it cannot be thought of in quality terms. Well, then what was another revolution was the entrepreneurial revolution. The whole Silicon Valley and the creation of new businesses and the social organization that came to surround that with venture capitalism and so forth was a massive revolution in how business is done. And it adapted to the creation bottom-up of new businesses with good ideas. And everyone's trying to figure out how to be the next Silicon Valley. But again, compare that to the university. We teach about entrepreneurship, but no one can argue that most of our universities are particularly entrepreneurial. And then finally, you come forward to the information technology revolution. So the creation of the microchip to the microprocessor to the personal computer to the internet, and the information technology revolution that we're in the midst of. And again, those things have had massive influence on our lives and how we do business internationally. And we teach those things and we study them as part of the university, but we do not use information technology in the same way that, say, Dell Computer or Walmart do. We do not have integrated supply chains that where we can understand exactly what's happening in our institutions at a moment's notice. So we are in institutions that are sort of sitting out many of the revolutions that have taken place from the Cold War till now, and it's it's a bit of a problem. I think that clearly on the outside our world is very different. Clearly on the outside we do have flat worlds. We do have projects that follow the sun. We do have plans going from Bangalore to Los Angeles at the speed of light. But we live in institutions that were products of the Middle Ages. University departments were products of German universities in the 19th century, and we really have not adapted how we do business to the world that we live in. Now, if you think about that from an economic perspective, it seems to me that there are two major forces. There are the forces of returns to network scales, some of the work that Brian Arthur did, has done, and others have followed, and then also the idea of transaction costs. So the work on network returns says that there are certain kinds of products and services that get more valuable as more people use them. And that wasn't particularly apparent, but if everyone uses a particular type of keyboard, that keyboard becomes more valuable. Or if everyone uses Microsoft Word, Word becomes more valuable. So the return to the user is greater, it becomes more valuable as more people use it. And the internet's that way, and many of the things that are part of our world now are that kind of network good that has those increasing returns. Counter to that effect is the whole notion of transaction costs. So Ronald Coase got a Nobel Prize for his work in the early part of the 20th century on transaction costs, and essentially transaction costs are the costs for using the free market. It's sort of ironic that we think those of us who think free markets are important don't often think about the costs of using free markets. And so one of the reasons organizations get big is to try to minimize transaction costs. If you have to hire, say, somebody every day, you'll hire them for a longer period and make them an employee as part of a larger organization to minimize the transaction costs on the outside world. And so it's the sort of tension between transaction costs and network effects that are really sort of different than the returns to scale kind of economics that dominated in the Cold War. And so we have all these things that have taken place in a historical sense, and we have these economic and technological forces that help shape our world, but then we live in these organizations that have not been very eager to adapt to the times that we live in.
And you talked about how over time we've become more advanced. We're connecting with third world countries, other countries across the globe, and that's going to lead to cultural interactions that have not happened on that scale ever. How do those play into this new entrepreneurial engineer and new economy engineer?
Well, I think it's very important, and many companies have to deal with this already on a day-to-day basis. I was talking to an executive at the Fluor Corporation, a man named Steve Gilbert, and talking about how projects today follow the sun, that somebody will be working in the United States, and as the project will move west and be handed off to teams of engineers elsewhere. And so this world's already upon us, and some of the problems that can occur are exactly the kinds of cultural differences that you mentioned. So, for example, there are people interested in this sort of thing. For example, the cultural anthropologist Gary Downey at Virginia Tech has very nice books and writing, and has written a number of papers about engineering culture, talks about engineering design culture, studies engineers as an anthropologist and tries to understand what are some of these differences. And so then the question is, how do we integrate that learning into the kinds of things that we teach the entrepreneurial new economy engineer? It seems to me those are important questions, and it raises the larger issue that a lot of what we need to know about the people side of engineering is embedded in the humanities and social sciences, with whom we haven't had a very good relationship or even any relationship for many years. So it seems to me that it's very important to build grassroots networks of faculty from engineering and the humanities, social sciences, the arts, to try to promote things. So for example, at Illinois, back in 2006, we created something called Engineering and Technology Studies at Illinois. And we got together people from history, philosophy, communications, art and design, and engineering to think about engineering as a human activity, and that led to a lecture series. And that grassroots network has played a pivotal role in some of the work that we've done in the iFoundry initiative in trying to reform the engineering curriculum. Some of those people did some of our. You actually asked me before about technology. We've been using things like YouTube to try to gesture at where the curriculum should go, and many of the people in those first videos were the historians, or we have a faculty member from Women and Gender Studies talking about women in design and so forth. So it seems to me it's those kinds of connections that we really have to make if we're going to do this right. And so it's culture. You asked specifically about the cultural effects and the effects of working globally, but it's as we need to understand all kinds of human effects, we need to reach out to our colleagues in the humanities and social sciences, at least those who are interested in engineering as a human activity, to try to build our knowledge base of those sorts of things so that we can educate better engineers.
You know, when you're working across these cultural boundaries and working with different kinds of people in different environments, it takes a certain self-awareness to be able to handle these situations, a certain emotional intelligence. So how important is that for engineers?
We think it's very important. At Illinois, we've had a class for a number of years called Emotional Intelligence for Engineers, and taught by my colleague Ray Price, whose background actually is very interesting. He's his PhD is in organizational behavior from Stanford, but yet he's a faculty member in the College of Engineering. So have an embedded organizational behaviorist in the college. But I think these things are very important. But right now they're not requirements, and they're usually have to take them as free electives. One of the things that we're doing is we're implementing the idea of a theme that allows students to organize all of their humanities and social science courses into what we call a HAPPY theme, which stands for Human Artifacts, Processes, and Interactions. And the idea is to choose roughly 3 classes, or 9 semester hours of coursework, organized around a coherent theme. Now the themes can be chosen from a pre-approved list, or students can fill out a simple petition to create their own theme. But the basic idea here is to get students to name and embrace the social science and humanities courses, and the hope is that rather than coming into my office and asking me questions such as, well, Professor Goldberg, is Psych 100 easier than Social 101, that they'll instead have some good reason as to why they're taking these, and be more thoughtful about the courses they're taking, and that they are part of their engineering education. It's something that that faculty value and feel that should be a part of, rather than just this kind of add-on that you sort of like a chrome hubcap or something that you throw onto the vehicle after to dress it up. That these courses should be more integral to what it means to be an engineer.
Wonderful. So you've provided a great amount of insight on the issue of the entrepreneurial engineer, and a lot of thought points for our new economy engineer. If you have one suggestion for the new economy engineer, what direction to go, what to study, just any thought or suggestion at all, what would that be?
My parting point would be to we've talked about what the new economy engineer needs to know that's different, but we haven't. And we've talked a little bit about the organizations in which being an engineer is taught. But I think that a critical element is to understand the organizational and political context of change if we are to change. The kinds of changes that we're talking about are potentially wide-ranging. If you want to, and you alluded to this before, that if we want to put things into the curriculum, that other things are going to have to give way. There is a certain logic there that's going to have to be obeyed. But in order to get there, though, we have to understand that the system of engineering education is itself a complex system, and that it will only change if certain pressures are brought to bear both inside the organizations that constitute that complex system and from outside the complex system to help shape it. And so it seems to me that an important part of this is the organizational and political dimension. And so at Illinois, one thing that we've done is to try to change the organizational dimension to make it possible to make changes by creating a collaborative curriculum incubator, and that's what iFoundry really is. We join together with the other departments to try to make change, but we're still respectful of faculty governance. We still, at the end of the day, it will be faculty who have to approve this. So it's not centralized control where we say, you will do this. It's, can we do these things together? And let's try some changes, and if they work out, then let's vote on them. So that's one point. But another point is that if say the University of Illinois changes or CASE changes, how do we get the larger system to change? That's this political dimension. And it seems to me that we need to come together and not necessarily suspend competition for new U.S. News and World Report's rankings, but we need to work together to understand that the real problem here is this curriculum invented during the Cold War, and that we have to go somewhere, and we're trying to figure it out in some principled and logical way. And so I think that we need to promote people coming together and sharing ideas. And certainly that has occurred inside of engineering education societies, but it hasn't occurred in a concentrated way focused on change. And I think that's what needs to happen. And so on April 1st at the Franklin W. Olin College of Engineering in Needham, Massachusetts, Olin College and the University of Illinois will co-sponsor an event called the Summit on the Engineer of the Future. And our hope is to have this political conversation about why change needs to take place. And at the meeting, we're going to have a signing of what we call the Transformation Proclamation by individuals, including students, including faculty, administrators, people in corporations. And the idea will be to say that something needs to be done to make engineering practice aligned, to make engineering education more aligned with engineering as practice. And so our hope is that by having individuals commit to this process of change, that will set in process the kinds of pressures and forces that need to be exerted in order to get this inertia-filled complex system to move. And so I think the key thing here, you asked me for one thing, I guess I gave you two, but it seems to me that we can't continue to neglect the organizational and the political dimensions of this problem. To think that somebody can write down a list or a plan for the new economy engineer and that poof, it will happen, ignores the history of difficulty that we've had in moving this complex system over the last decade and a half or so. And so I think we need to focus like a laser beam on the organizational and political dimensions. And it's still going to be hard, and it's still going to be a difficult challenge, and there's a lot to figure out. But I think if we focus on those things, that we've got a chance.
Well, thank you very much. I appreciate you coming out to Case Western Reserve University and spending time here with the interview.